Okay, this is 8.6 or 10.65. At 250 feet, the pressure is 250 feet underwater. Pressure is 8.38 atmospheres. And it says that what should the mole percent of oxygen be in the diving gas for the partial pressure of oxygen in the mixture to still be 0.21, which it would be in air at 1 atmosphere pressure, like in the room or somewhere like that. And kind of the way to see what's going on here might be to look at these two containers here. On this first one, you have 1 atmosphere of pressure represented in here. And you notice that the oxygen takes up a fair amount of space because at 1 atmosphere pressure, 0.21 atmospheres is about 20% of the total. But then if you looked over here on the second one, alright, at 8.38 atmospheres, which is a whole lot more, right? Well, this wouldn't even be to scale, but to indicate 0.21 atmospheres when the total is 8.38 atmospheres, the amount of oxygen, or the mole percent of oxygen in this whole thing, is much less. This is a much smaller quantity than this. Not quantity in terms of it's the same pressure, but the amount of oxygen that's going to be in this is going to be a much smaller percent of the total than it is over here in the first picture. Okay, so that's one way to look at that. Okay, and then the question in the book was what mole percent. Well, remember, a mole percent in this case is just like a mole fraction multiplied by 100. And usually we're going to use mole fractions. And if you look at your cheat sheet, get your cheat sheet out on the gas laws, you notice this kind of weird looking X is the symbol for mole fraction. So X1, for example, equals mole fraction. And according to your cheat sheet, you have that the mole fraction of a gas is equal to the moles of that gas divided by the total moles, or pressure of that gas divided by the total pressure. Okay, so this is pretty simple. We want to get the mole fraction. They actually ask for mole percent, but we'll give them the mole fraction, and then you can multiply that by 100. But basically, it says that the total pressure 250 feet below the surface. Now this is the pressure on the diver's body. I'm not a professional diver, so I'm not exactly sure how this works, but you have to have the same amount of oxygen at that level as you do at the upper level. So you want the pressure from the oxygen to be the same, or the mole fraction of oxygen in what you're breathing to be the same as it would be in the air. And so it tells us, in this case, giving us pressure, that the total pressure was 8.38 atmospheres. But we want to keep the pressure from oxygen, the gas we're looking for, the same as it would be if we were just standing in the room somewhere, which is 0.21 atmospheres. Alright, so if you divide those out, 0.21 divided by 8.38, you're going to get 0.0251. Now that's the mole fraction. So this is mole fraction. And then if you multiply that by 100, so 2.5% oxygen. Alright, so that would be the mole fraction of oxygen. So in other words, it's going to be a much smaller portion of the whole thing at that higher pressure than it would be at room pressure.